This is the pre-exposure for the process to finding inverse operations, but I just want to generally remind everyone what an inverse operation is, and that's if you start with an x and you apply a function f, you get out a y. If I were to put y into the inverse function of f, I would get back x. So, you know, you're undoing, if you will, the original function. So an inverse undoes the original function. I can write that down here. That's so tight down here. Inverse undoes, I don't even know if that's a proper word, but I suppose it is. Undoes, that's why I'm a math teacher, right? The original function. Okay, so I put together a simple procedure on how to find it. And the very first thing that you need to do to find an inverse function is to apply the horizontal line test. So that's step one. And recall the horizontal line test. If you have a function and you pass a horizontal line through it, if it only strikes 1 point at any given time, exactly 1 point, then that function has an inverse. So good rule of thumb is to always do the horizontal line test first on the function. Graph it. You can use Maple. You can use your graphing calculator. Graph it. Look at the pass the horizontal line test through it, and make sure that it passes it. And then you can proceed to step 2, which is take an equation for f of x and replace f of x with y. Just recall, you know, that f of x is equal to y. So that's your second step. Your third step is to interchange the roles of x and y, so swap them. Swap x and y. And the fourth step, after you swap x and y, I'm sorry, I skipped the most important part. After you swap x and y, you have to solve for y. That's your inverse, the answer. You can replace y with f inverse, and you have the inverse function. And then lastly, a good rule of practice is to verify that they indeed are inverses. And this is a property of inverse functions. If you take the composite, and you have to do it in both directions, of f with its inverse, that has to equal x, and the other way, f inverse, composite with f of x. Both of these conditions have to pass for f and f inverse to truly be inverses of one another. So if you're asked a question, are two functions inverses of one another, then you would need to do this verification step to prove that they both equal x when composited together. Okay, I want to do an example at this point, and I'm going to pause and do a little bit of writing so I can keep the video shorter. Okay, I'm going to do textbook number 27. The function is a root function. Specifically, f of x is equal to the square root of x plus 2. So hopefully you recall from your transformation refresher that the root function looks like this, but our function has a transformation. You're adding 2 in the x direction, so you move to the left, so this function looks like this. So indeed that this passes, let me grab a red, this passes the horizontal line test. So the first thing you want to do is just check it. Right? So this passes the horizontal line test, which means the function f of x is 1 to 1. So it has an inverse. Good news. Now we can continue. Step 2, replace f of x with y. So all that I'm doing is rewriting the original function with x's and y's. And then I'm going to swap x and y and solve for y. Alright, so this becomes x equals the square root of y plus 2. So now solve the equation for y. You have to square both sides to get rid of the square root. So this is x squared equals y plus 2. And x squared minus 2 is equal to y. So this is indeed your inverse. So f inverse of x is equal to, which is your fourth step, is equal to x squared minus 2. Let's verify it. Now this may take a little bit more work, but you really do need to take this last step into consideration. So we're going to verify this work that we've done, because you could have had an algebraic mistake, but let's verify it. I'm going to find the two composites that I mentioned on the review slide a minute ago and verify that they both equal x. Okay, so let's do the first one. F of f inverse. Well, f inverse is defined as x squared minus 2, so I'm going to substitute directly in here, f of x squared minus 2, and put that into f. F is x squared minus 2, which is x, plus 2. So this is simply the square root. These are going to cancel out, and you're left with the square root of x squared, which is equal to x. So that's good. We got one of them. And the other way, f inverse, f of x is the square root of x plus 2. And I'm going to put that into our inverse function that we found. And that is x squared plus 2, right, squared minus 2. And that's equal to x squared plus 2 minus 2, which equals, oh, I got a problem here. I'm so sorry. I added a square on here for you. Shouldn't be making these videos so late, right? This is the square root of x plus 2 squared minus 2. All right, that's the definition of f inverse. And this is simply x plus 2 minus 2, which equals x. So therefore, f of x, which is equal to the square root of x plus 2, and f inverse is the one we found correctly. So we verified it. Okay, that's it.